7.2, verifying trig identities. So here are some hints that you can do. And verifying is not solving the equation. So you can't add something to one side of the equation and add it to the other side. You can't multiply one side by another side. So you work one side first, starting usually with more complicated side, and you want to substitute different things in. Those fundamental identities, that's what you want to substitute in. Those fundamental identities that we learned from last chapter in chapter 5. And sometimes you want to write it in basic sine and cosine, so you turn everything to sine and cosine. That can be one strategy. And then whenever you can do any kind of operations like add fractions, separate a fraction into two different fractions, factoring, rationalizing a denominator, like when you have conjugates like this, 1 plus sine x or 1 minus sine x on bottom. So if you multiply by the conjugate, when we multiply these two conjugates, we get 1 minus sine squared x, which is cosine squared x. So whenever you have this type on bottom, then you can multiply by the conjugate, and then you'll get a Pythagorean identity. So you always want to, very last thing, you want to keep in mind where you're going. So always look at what you're trying to get to, what trig function you're trying to get to, and what are you given, right? Do you have a fraction on one side? Well, how do we turn what you have into a fraction, right? Reciprocal identities. If you have two terms where you're going, right? If you have one thing minus another thing, then try to turn your thing into two terms, right? Always keep in mind where you're going. All right, so let's go ahead and practice a couple. So here we go. So first thing we can do is we can distribute this to both, right? So cosecant of theta times cosine of theta plus cosecant of theta times sine of theta. And we know when we have reciprocals, right, cosecant and sine, that they're going to cancel out to 1, right? Because this is, cosecant is 1 over sine. And I'm timesing that by sine of theta, so those are going to cancel, and I get 1, right? Reciprocals always cancel, okay? As long as they're both to the first power, or if they're both squared, then they will cancel. They're both 3, they will cancel the 1. Okay, and then I can switch cosecant to 1 over sine, because maybe I don't know where I'm going, right? But I do know I need a plus 1. Well, I got my plus 1. Right, so I got my plus 1 part. Now I need to get cotangent. Well, I have this. How can I get to cotangent? Well, I can look up what cotangent is. Cotangent is cosine over sine. Right, so that means somehow I gotta have a cosine, which I do have this cosine, right? Now I need a sine. Well, again, cosecant is 1 over sine. And now I can times something whole number, right, by a fraction, top times top, so cosine times 1 is cosine of theta over sine of theta, which is cotangent. So then I have cotangent of theta plus 1, and that's what I'm after. So the left-hand side equals the right-hand side. So there's lots of different ways that you can do these, but lots of different ways to do them. So make sure you show your work. Your work here. Oops. Your work here is your answer. I will go back through and make sure you do the correct things and make the correct substitutions. Okay, so you can't just at the end say left-hand side equals right-hand side, done, right? And these verifying ones will always be true. So there won't be one that you can't do. You will be able to do all of them. Okay, so sometimes you can go anywhere you want to. So here I'll do the easiest way. This, right, we can look up as Pythagorean identity is cosecant squared of theta. So we'll go ahead and substitute that. Cosecant squared of theta. And then we're trying to get to a fraction, right? So we might want to turn these into sine and cosine. So tangent squared is sine squared over cosine squared, right? If it has the square, that means it needs a squared here. And cosecant is 1 over sine. So I'm going to change that to 1 over sine squared. Now I'm multiplying fractions, so I can cross cancel. So I get 1 over cosine squared. So that's how I got to a fraction, right? I needed a fraction, so I started creating fractions. Now I can take this fraction, and I have cosine squared on bottom, and I need 1 minus sine squared. Well, that's my Pythagorean identity, right? Cosine squared is 1 minus sine squared. So the left-hand side equals the right-hand side. Okay, the harder, maybe a harder way, maybe not. Just depends on how your brain thinks. You might start things differently. It's just if you've ever played, what's the one, like catchphrase, you know? Sometimes when different words pop up, they have different meanings, so you act on it in a different way. Like if you have the word bat, then you might act like a flying bat. You'd flap around and try to have people guess that, or you might swing like as in baseball or softball, you have a bat, right? So there's different ways to go about it to get the same answer. Okay, so just because I do it one way doesn't mean you can't do it another way, but it just has to make sense, right? You have to use the proper things. Okay, so instead of switching, I'm going to distribute this tangent to both. So tangent squared x plus tangent squared x cotangent squared x. Now these are reciprocals, right? Because cotangent is 1 over tangent. So that means cotangent squared is 1 over tangent squared. And so those are going to cancel out to 1. Don't forget my x. So I get my plus 1. But then I have this, right? So maybe I don't know where to go here. But I know that, hey, so there's two different ways to go here, too. This is secant squared x, right? So that's secant squared x. So I could substitute that. Then I say, hey, I need a fraction, so how can I create a fraction? Well, that's 1 over cosine squared x. Then I can switch my cosine like we did before in the last one, 1 minus sine squared x. Or I can say, hey, I need a fraction, right? I need a fraction here. So I can take tangent, and I can do sine squared x over cosine squared x plus 1. And now I need a common denominator, so I can go cosine squared x over cosine squared x, and plus sine squared x over cosine squared x. Now I have a common denominator, so now I can go ahead and add the top, so I get sine squared x plus cosine squared x. So see how there's so many different ways to go about this. Now my top, I can look as Pythagorean identity is 1, and then cosine squared x will turn to 1 over 1 minus sine squared x. So see how there's several different ways to get the left-hand side equals right-hand side. And I'll just follow and make sure you do the right thing. That's how I grade these. So it's really terrible to grade these because it takes so long. But that's all right. Okay, here's another one. So start with the more complicated side, right? So maybe this fraction. So here we have a fraction. We have a binomial over a monomial because this is multiplication here. And t, if you want to switch that to theta or x or whatever you want to switch to, that's fine. Okay, so here we have a one fraction. I'm going to go ahead and separate it into two fractions over this common denominator. So tan t over sine t times cosine t minus cotan t over sine t times cosine t. So sometimes it just takes more practice and more practice to keep going. So that's why you should probably do the homework that I assigned you in this section and practice it, and maybe practice some more on top of that. Okay, so then I can go ahead and say, hey, now I have, because I noticed why I separated this two fractions, because I have two terms here. So I need to do two terms with a minus sign in between. So now I have two terms with a minus sign in between. Now I probably should switch everything to sine and cosine. So tangent is sine over cosine. And cotangent is cosine over sine. And again, there's lots of ways to do this, so don't get stuck on one way. Okay, and then we can go ahead, a few different ways to do this. Multiplying or dividing by a number is multiplying by the reciprocal, or I can multiply every term here. I can multiply top and bottom of each of these fractions by cosine, and that would start canceling stuff out. So there's lots of different ways to do here. I'm just going to go ahead and take my numerators and multiply them by the reciprocals of the denominators. So multiply by 1 over sine t of cosine t, and this one cosine t over sine t times by 1 over sine t cosine t cosine t. So here my cosines will cancel out. So I get 1 over sine times sine is sine squared t. Here my sines are going to cancel out, so I get 1 over cosine times cosine, which is cosine squared t. Now I don't need fractions, right? I need whole numbers on top, right? So I need to flip these. Well, I can flip them by writing the reciprocals, right? So secant squared t minus cosecant squared t. And that's what it looks like, right-hand side. So the left-hand side equals right-hand side. So sometimes you'll have to work both sides, or both sides. This one's still not both sides, but that's okay. I think the next one is both. So this one, what I can do is I can multiply when, like step number 7, I think, when you see this, you can multiply top and bottom by the conjugate, right? So I can multiply by the conjugate here. 1 plus sine x, 1 plus sine x. So this one, conjugate's going to be 1 minus sine squared x. And the top one I'm just going to leave as 2 binomial times a monomial. I could distribute that, but I need, over here, I need this on top, which I do have right here. I just need to get rid of that cosine, right? So I'm going to leave that instead of distributing it. Okay, so now I'll leave that. But on bottom, I need a cosine, right? So I'm going to switch this. 1 minus sine squared is cosine squared x, but I need a single one, right? So somehow I need to get rid of this cosine and 2 of these. Well, you could separate this into 2 fractions, but this one is by multiplication, right? So that means cosine squared x here, and then I could do a whole number here, right? So just like I can multiply like 1/2 times 3 as 3 over 2, I could separate it to 1/2 times 3. That's what I did here. Well, the same thing is kind of true even more. I could really actually, there's 2 cosines on bottom, so I could put actually, so it would be something like this, maybe like 3/6. I could separate that to 1 over 2 times 3 over 3, because 3 times 2 is 6, and 1 times 3 is 3. Or these are going to cancel out, right? One of those is going to cancel out because there's really 2 of them there. One's over here, and one's over here. So these will cancel out to 1, and then 1 times this is just 1 plus sine x, cosine x. Forget my angle there. So left-hand side equals the right-hand side. Okay, now this one you're gonna have to work both sides. Okay, so working both sides, you just take one side, you keep on going until you can't go any farther, and then you jump to the other side. So there's lots of different ways to do this. You look in the book, it might do one way. You have your friend do it, they might do another way than you. So there's lots of different ways to go about this. I see on the right side I would need sine and cosine, right? So I want to turn all these things into sine and cosine. So this is secant is 1 over cosine. This is alpha. You can change that to an x, a beta, whatever you want. It's just the angle. And tangent is sine over cosine. And secant, same thing. This one is just subtraction. Okay, so one thing you do here, you can combine these fractions into one, or you could just multiply every term by cosine of x because they have that same denominator. This is kind of like complex fractions that we did, right? So we can multiply every single term by the least common multiple to get rid of those denominators. And we can do that because we're multiplying on top and bottom by the same thing, so that's not changing these fractions at all. Or we can go ahead and combine these fractions because they have common denominators. So we get something like this. Oops, common denominator, don't forget that, off the top. And then on the denominator we have 1 minus sine of alpha over cosine of alpha. Then you go ahead and multiply top and bottom by cosine of alpha, because that would take out the bottom. Or right when we're dividing by a fraction, we can flip it and multiply. So that basically means that these cosines are going to cancel out. So we get 1 plus sine of alpha over 1 minus sine of alpha. Okay, so we have that. So now I see, hey, I don't know where to go any farther than this. So then we jump to, because I need to have a fraction with 1 plus sign, so I got everything in 1 plus sign. But now I look at my right hand side and go, I don't know how to get there from here, right? So what you can do is now start working the right hand side. So I jump over to the right hand side and say, hey, I know what this is. That is 1 minus sine squared. And you might not recognize that this top one is something that looks like this. It looks like a quadratic, like this, x squared plus 2x plus 1. Right? I have something squared. I have something, that same something times 2, and then a plus 1. Well, that's a quadratic, right? Well, what do we do to quadratics? We can factor them. So I could factor this to x plus 1 times x plus 1. Right, something plus 1 times that same something plus 1 gets me something squared plus 2 times that same something plus 1. So that something is the sine of alpha, right? So we could factor this to the sine of alpha plus 1 times the sine of alpha plus 1 all over 1 minus sine squared x. So we look kind of where we're going here. Say, hey, well, so we need this 1 minus sine alpha, 1 plus sine alpha. Well, I already have 1 plus sine alpha. I just have too many of them, right? So can I take one out? Can I undistribute one? Because if I can have one cancel out, if I could take a sine alpha plus 1 out of the bottom, right, then I could cancel those out, and I would have sine plus alpha over 1 minus sine squared. Well, so there's two ways that you could do it here. One would be, you could look at, say, I don't know how to go from that. I don't know what to do here anymore, so I'll stop. Now I go over here and say, hey, I have 1 plus sine alpha right here on top. I need 2 of them. So what if I multiply top and bottom by 1 plus sine alpha? Wouldn't that give me 2 now on top? So I would have to do the same thing to the bottom, right? Because that wouldn't change the value of this fraction here. So I could distribute that, and I would get 1 plus sine alpha times 1 plus sine alpha on top, which that's what I need, right? And on bottom, I have conjugate, so I have first times first and then last times last, which could be a sine times a sine, which is sine squared, and a positive times negative is a negative, and that's what I need, right? So left-hand side does equal right-hand side. Okay, so that's how you do more complicated ones. You have to maybe jump back and forth. So we're going to go ahead and do some problems here. Okay, so on page 642, there's 35, 39, 43, 49, 65. Okay, so we'll start with number 35. And I would recommend even trying some of these on your own, trying some of these other ones on your own. And just do the odd ones so you can check the back of your book. Even the back of your book might not probably give exactly kind of how to do it. So you might have to check the back of the book, see what the back of the book says. But here we're going from cotangent of theta over cosecant of theta, and we want to make that look like cosine of theta. Well, we need cosine, right? And these are cotangent and cosecant, so we probably should put them in signs in terms of sine and cosine. So cotangent is cosine of theta over sine of theta, and then I'm dividing by cosecant, which is multiplying by the reciprocal. So if I multiply by the reciprocal there, the reciprocal of cosecant is, well, let's just flip cosecant, which is 1 over sine of theta. So now I can go ahead and multiply by the reciprocal, which is sine over 1. So then my sines will cancel out, and I get cosine of theta. So left-hand side does equal right-hand side. So there's lots of different ways, like I said, that you can get here, but there's one way. Okay, so several different ways to do this one. I think the fastest probably is taking tangent squared plus 1 using Pythagorean identity, which is secant squared of theta. And I'm timesing that by cosine squared, which these are reciprocals, right? So that means they're going to cancel out to 1, and that's what we're looking for. We're looking for 1. So left-hand side does equal right-hand side. Okay, so you could have distributed that and then rewrote tangent of sine over cosine and distributed that, because we know one Pythagorean identity is something like this, right? So if I distribute that, I would get my two terms, and then the sines would cancel, the cosines would cancel out when I distribute the cosine, and then I would have, so I'd have cosine right here, and then when I distribute this, the cosines would cancel out, so I'd get left with sine, and that equals 1. Right, so there's a few different ways that you can do that one. Okay, so here's a problem for you, number 43. So sometimes you'll be like, oh, I see this right away, and you'll go for it, and then you'll be like, oh, that's taking me a lot longer. So sometimes it might take you a lot longer, sometimes it might be quicker. So what's popping into my mind right now is that, hey, I'm trying to get to secant. I'm trying to get to secant squared, and I'm trying to get to tangent. So I already have a secant here, right? And tangent is sine over cosine, so somehow if I got a cosine on bottom here, and then maybe we can get there, right? But this subtraction thing means something's going to switch about this, right? So what we might do is I'm just going to go ahead and get in terms of maybe sine and cosine, which, because I can do right away, right? I can move this to the top, which will be multiplying by cosine. So I would get cosine squared alpha. This one, same thing. I move to the top, so I get cosine squared alpha, and then sine squared alpha. And that equals 1. So now I'm at 1, so I have no idea where to go from there to get secant squared and tangent squared. So what I can do is I can maybe jump to the right side and try to get 1 out of this. And I know that secant squared is tangent squared plus 1, or tangent squared of alpha plus 1, sorry, and then minus tangent squared of alpha. So these tangents would cancel out, right? I can do that math. Tangent squared minus tangent squared is 0, so I get 1. So there we go, 1 equals 1. So lots of different ways that you can do this. Maybe you can move that cosine to the bottom because you think, oh, I need to turn in terms of secant. Maybe this is not the most complicated side, so maybe I start on this side. Right? So lots of different ways. So left-hand side equals right-hand side. Right? They both commonly equal 1. Okay, so here we go here. I might think, hey, I need a secant of theta minus 1. And I need 1 fraction. Well, maybe I can switch this cosine over and separate this into 2 plus 1 over tan squared alpha, and then switch this squared one to dividing by is multiplying by the reciprocal. So cosine of theta times cotangent squared of theta. So this might be the long way. I'm just kind of thinking and just going for it. So sometimes you just got to go for it. Sometimes think about it a little bit more, see what you can do. Cotangent is cosine squared over sine squared. So maybe I'm going to start all over here. I don't know. And then 1 over tangent would be just cotangent squared of alpha. So here I'm not really doing anything significant. So might have to start all over here. Well, maybe start over, but I'll start over on the right. So I'm going to multiply this, because I know if this is squared, then that's tangent squared, and that's what I need to the left is tangent squared. So if I multiply this by the conjugate on top and on bottom, As long as I do it to one side, right, on top and bottom, I'm okay. So we get cosine of theta times secant of theta plus cosine of theta. These cancel out to 1, so I have 1 plus cosine. Hey, 1 plus cosine, that's what I need, right? And on bottom, I have conjugate, so I'm going to get secant squared of theta minus 1, which is tangent. So there we go. Hey, so I messed up. I just went for it, and I couldn't get there, and I got stuck. So I got stuck down here, so I'm like, that looks a little complicated, and I'm not going to get to here to the right. So I started at the right and noticed that, hey, that kind of looks like if I'd had the squared, then that would be tangent, right? So I multiply the conjugate on top and bottom. So there you go. So this is done, but left-hand side does equal right-hand side. So sometimes it sucks, but you have to restart. Okay, so I wrote the first one on the left side a little bigger here so that I switched the right-hand side and the left-hand side, but it doesn't matter. It's equality, right? So I'm thinking, hey, maybe start with the right because that's what I, can do. I have two fractions. Maybe put it into one because I need one term here. So maybe I need to get this to the right into one term. So I need common denominators, right? So this one I have to multiply by the conjugate on bottom. And this one on the right, I'm going to have to multiply by the conjugate as well because I need that common denominator. I have 1 minus cosine x and 1 plus cosine x. So on top, you're going to have to distribute, right? You're going to have to FOIL that out. On bottom, they're conjugate, so it's nice. It's just 1 minus cosine squared x, which is not quite, well, which is just sine, right? But on top, we're going to have to FOIL this. This is 1 plus 2 cosine x, cosine squared x, plus cosine squared x. And this one, I have the same thing, except for it's minus, so I don't have to distribute that negative, or I could do it now, that's fine. Minus 2 cosine x plus cosine squared x. And then distribute that negative, so that's negative 1, positive, and a negative. So it's been distributed. So that negative 1's cancel out here. The 2 cosine plus 2 cosine is 4 cosine x. And then the tangent squared cancels out. So I have 4 cosine x over 1 minus cosine squared x, which is sine squared x. Okay, and then we can look where we're going and say, hey, I don't know exactly how far, so maybe I need to start at this side and go tangent is 1 over well, let's not do 1 over because I don't want to bring that down. So let's go switch cotangent to cosine, I forgot the x up here, cosine of x over sine of x. And there's 4 of them, so you can put that 4, just leave it on top. And then cosecant is 1 over sine. And then sine times sine, so 4 cosine x on top. And then sine times sine is sine squared x. And is that what we need? Yep. So left hand side does equal right hand side.